All right. The third question: two identical balls collide head-on. So the first thing we need to note is since they're identical balls, it means M1 equal M2 equal M. Okay. The initial velocity of one is okay. So we say U1 is actually 0.75 meter per second east. It means we'll take the east positive. Okay, why that of the other ball is U2 is 0.43 meter per second west. It's very, very important. Okay, minus, since all these are vector quantity, that's the velocity, so it's very important that we indicate minus to show the direction. Okay, so since there are so this momentum is conserved in the collision, okay, and it's an elastic collision, we have to find the final velocity. So we're looking for v1 and then we're looking for v2. Okay, so we need to find the final velocity of each of those balls. All right, since the momentum is conserved, it means momentum before collision equals momentum after collision. Right, so we write the formula mu1 plus mu2 equal mv1 plus mv2 since it's conserved. So m u1 is 0.75 plus m u2 is minus 0.43 equal m v1 plus v2. All right, I'll factorize the left hand side too. M is actually 0.75 minus 0.43 equal m v1 plus v2. M we cancel this, so 0.75 minus 0.43 equal 0.32 equal v1 plus v2. I'll tag this equation 1. All right, since the momentum is conserved, it means that, and it's perfectly inelastic, it means the kinetic energy also is conserved, and then that's kinetic energy before collision equals kinetic energy after collision. So I'm going to write the formula to half m u1 square plus half mu2 square equal half mv1 square plus half mv2 square. Okay, so I'm just factorize 1/2m out, so we'll be having 0.75 square plus minus 0.43 square equal half m v1 square plus v2 square. So this we cancel this. Right, the simplification of this after squaring it and adding it should give us 0.7474 equal v1 square plus v2 square. I'll tag this equation 2. So we are going to simplify v1 and then v2 together, and then we're going to get our solution. So from v1, from equation 1, it means that v1 equals 0.32 minus v2. I will tag this as equation 3. So tagging this as equation 3, I will substitute this value inside equation 2. So it will become 0.7474. Let me see, equal 0.32 minus v2 all square plus v2 square. Now this actually is an expression on its own, and this means that is 0.32 minus v2 times 0.32 minus v2. All right, after expanding all of this, we are going to be having 0.1024 minus 0.64 v2 plus v2 square. That's this multiplied by this multiplied by this, and then after doing all of that, that's what we're going to be having. But the formula, we're going to now substitute this value for this value. So we'll be having 0.7474 equals 0.1024, right, minus 0.64 v2 plus v2 square plus v2 square. Now the simplification of all this now will give us 2 v2 square minus 0.64 v2 minus 0.645 equal 0. Now using formula method, minus b plus or minus square root of b squared minus 4ac over 2a. So now comparing, okay, I said comparing. What are we comparing? Okay, let me say a v2 square plus b v2 plus c equals 0. All right, this is the general formula of quadratic equation. Right, comparing them together, that's comparing, let me say this b, let's say a, comparing a and b together, it means that a equal to b equal minus 0.64, c equal minus 0.645. Now substituting it in the value, it means v2 equal 0.64 plus or minus 0.64 square minus 4 times 2 times 0.645 over 2 times 2. All right, so we have 0.64 plus or minus minus 0.64 square plus 5.16 over 4. All right, the solution to all this now, 0.64 divided by 4 will give us 0.16. So it means v2 equals 0.16 plus or minus 0.59 meter per second. So actually that's the value for v2, and since it's plus and minus, it means v2 has two different value. All right, from this v2 is at 0.75 meter per second, or v2 equal minus 0.4543 meter per second. All right, so these are the value for v2. Now if we go back to equation 3, that's this one. It means v1 equals 0.32 minus, let's put in each of this value as 0.75, and putting in the value for this should give us minus 0.43 meter per second. So it means at v2 equals 0.75 meter per second, it means v1 equal minus 0.43 meter per second. Let's go to this. v1 equals 0.32 minus minus 0.43. So V1 equal 0.75 meter per second. So it means at V2 equal minus 0.43 meter per second, it means V1 is equal to 0.75 meter per second. All right. So actually we can't choose the two value. We need to discard one. So we are going to be picking V1 equal minus 0.43 meter per second, and then V2 0.75 meter per second. We are going to discard the second one. The reason why we're discarding the second one is because from the value we have in V2 as minus 0.43 meter per second and V1 as 0.75 meter per second, it implies that the ball continue unchanged. That is to say, there is no collision. Collision did not occur at all. So therefore, the values we're going to be picking, we'll be picking V1 as minus 0.43 meter per second and V2 as 0.75 meter per second. Now, since they are vector quantity, the vector quantity for this, as the speed will be 0.43 meter per second due west, and V2 will be 0.75 meter per second due east. All right, so this is the solution to that question. Thank you very much.